Hey world, so wonder what we have here. It's just a little box. Wonder what could be inside this thing. Oh, well, I've been on the internet and let's see what I found. Okay, let me open this box up here and we'll see what's what. See if okay, so made a few cuts into this little packaging material here. Kind of thick black tape stuff, kind of rubbery, kind of cool. Yeah, kind of wild stuff. Hey Throttle, if you know what this is, let me know. I don't know what this kind of weird stuff. Maybe it's just, anyway, a little black. Maybe it's just kind of some kind of weird tape. I don't know. So, look what I got off the internet. INKBIRD microcomputer temperature controller. So I'm thinking, I don't know if you guys have tried these. Let me know if you have. I'd like to know. This will be my first INKBIRD to open up here and see what's what. So I'm guessing these things should be like a Corel or any of these new digital controllers we got out here. But the clincher is here. Check this out. I got a little 12-month warranty card. INKBIRD seems like it might be kind of maybe a decent company. We'll see. They seem kind of like a big name out there. They look like the beer guys or something. They're doing a lot with the heating and whatever they do with beer, making beer. Check this out. This is kind of a nice box. And I think we got a little thermocouple in here, or actually it's probably going to be a thermistor, which would be a variable resistor. So sensor's got to be, this has got to be the sensor, the thermistor. Yep, there it is. Peeking into the black ones, got a little nubby. Okay, so, and here's the little controller. Hey guys, you know what I'm looking for? Does anybody know, I've been searching kind of high and low on the net and I haven't seen it or found it yet, but does anybody sell just a metal panel or even a plastic panel that has the cutout pre-made for these controller panels? You know, this has got to be a standard size. So if anybody knows of a link, or I'd love to buy, I want to buy a half a dozen, you know, boxes or something where I can put this in it, or at least have a panel that I can mount a panel somewhere and then stick this in it, you know, because I want to, what I'm wanting to do here is I never use the relays in these things to take full compressor amps. You're just asking for trouble. So I always will run a contactor with them. So that's just how I do it. That's my personal preference. But this thing seems pretty cool. I'm guessing the ITC-1000F. I believe that's the model number. 110 volt one. This is the one I got. So we got power supply coming in on 1 and 2. Looks like here. 3 and 4 looks to be the thermistor hookup. I'll confirm with the instructions, but then our cooling or heating relay, whichever you would be doing with this. Get 2 sets of relays rated at 10 amps a piece, 10 amps at 110 volts. So it could be 20 amps if you're breaking one leg. Well, no, I wouldn't go over 10 amps or whatever voltage. Your current, you want to watch your current on these things. I wouldn't even run more than 5 amps across these things. That's my limit. It's 5 amps. That's why I run it with a contactor. Then the contactor just burns up and you throw the contactor away and put a new contactor in. You never ruin your controllers, you know. But so these controllers are quite a bit cheaper than what we can buy them for at supply houses. Or what, you know, their retail. I think these things are $100 or something, retail, you know. So, but these are pretty inexpensive. So I'm gonna try these things. I'll power this thing up. Hopefully I'll add that. I might add that to this video and power it up and see what it looks like and go through it, and that'll be some fun. But this thing feels well made. Feels just as good as a Danfoss. Looks nice too. Looks cool. It's got screw clamp down type terminals. You got to pull off this rear screw to expose the wiring. But yeah, just use a relay or a contactor with these things and you'd be golden. And don't get them wet. Don't put them in an outdoor. Put them in a waterproof box if you're going to put them outdoor. You know, and should be golden. This thing feels good. It's heavy. It's got some weight to it, man. It's like, I'll bet it's just as good as any Corel or Emerson out there. Probably the same one, just a different badge on it. Probably made in the same factory. But anyways, I'll power this thing up. I'm jazzed now. That's cool. Alright, thanks for watching, guys. Click like on the video and subscribe. Thanks, bye. Okay, world, how you doing? Yeah, excuse me. This little video is about how to tell which wire on your electrical outlet is hot or neutral or ground. So we know the round one in America, United States, the round one is ground, so that's the green wire. Okay, so if you take your meter leads and put your black one on ground and your red one to each other individual one, that will tell you which one is the hot. So I should have brought in my alligator clips, so I'm going to try to do this. Oh man, this is going to be difficult. Let me try something. Hang on a second here, guys. So let's do this. Okay, if you don't have alligator clips handy, you can always do like what I just did here and wrap the wire around the negative on your meter. Okay, so we got that there on your meter. Okay, and here we have the meter. And what our setting on our meter is V for volts, and the S line on its side is that means alternating current on a meter. The V for volts above it, if I were to switch to this one, that's volts DC, because it's direct current. That's the straight lines. Okay, so that's batteries. That's what you would use for testing batteries, like your car battery or AA batteries, AAA batteries, or that kind of stuff. So V is for volts, A is for amps on the other settings down here. That's amps DC and amps AC, alternating current. AC stands for alternating current, DC stands for direct current, and DC is batteries. Okay, so I'm going to go over here to I got one of these wires, this one or this one, is going to be the line wire, or the hot wire, and one's going to be a neutral, and the green is the ground. So I'm going to take and touch this to this wire because it goes right in there, and I have 120. So that tells me that is the line wire, and that is the one I do want for the line wire. For this wiring in this little INKBIRD controller right here. Got it off the internet, and I'm gonna see how I like it. So far I like it. It feels robust. The switches, the buttons feel very nice. They have a nice click to them, a nice feel. It's heavy. Doesn't feel all like junk. It feels just as good as any of the Dixels or Emersons or Danfoss pieces of junk or anything else like that. So this is this. Here's your wiring diagram. 1 and 2 is your line, is your power in. I don't know if these controllers, I looked in all the directions and everything to see if there is a parameter that says anything regarding if it's polarity sensitive, you know, like furnaces are. At least new furnaces that have been made since the 90s. So this is how to wire this. So your sensor is going to be on 3 and 4. Your thermistor is going to be on 3 and 4, and there's your they got 2 relays, just a set of contacts basically, and they're rated for 10 amps. So that is 10 amps. Turn this sideways for those of you that don't like to read sideways. There we go. So yeah, 10 amps, and they're just a set of contacts. So one's for heating, one's for cooling, I guess. And anyways, I'm going to be using the cooling one because I'm going to be using this for refrigeration, for controlling refrigerators and freezers. So that's what strictly distinguished interface of relay, sensor, and power. That might mean sensor down lead. Okay, so I'm just taking the abundance of caution and I don't want to junk this controller out. So that's why I'm finding which is the hot and which is the neutral wire. Because it says on this little thing that comes with it, the line wire and the neutral. There's your, so. Okay, so I'm putting my line, which is correct, to number 1. And this is what you would get if you put it to the neutral one. You get nothing. Okay, so yep, and there's nothing to that wire there. So this is your hot wire right here, 120 volt between this wire and ground. So that's your hot. And so let me hook up the other wire. I'm gonna get a tripod and a little stand for this, for my iPhone here, and to do this hands-free. Anyways, let me hook up the other wire, the neutral to the second, number 2, and then let me hook up the thermistor, and I'll get back to you. Okay, we're firing up the INKBIRD controller for the first time. Let's see what we get. Turn the power on. And it's a noisy little bastard. Why it's doing that error is because it has an alarm built into this thing when the temperature exceeds the limit or when sensor error. So if this thermistor gets a open or a short, which right now it's open, you get an error on the front and you get that alarm, and you just touch any of the buttons, push any of the buttons to silence the alarm. And I don't know what, like, if the alarm comes back on in like 5 minutes or 15 minutes, or if it's silenced forever, but I know that if you were to unplug the unit, you know, like power the whole unit back down and then turn it back on again, you'll get the alarm. So it's quite piercing, quite the noisy little alarm, which is kind of cool. So you can set a high limit on these alarm and a low limit alarm, I guess exceeds the limit, or just maybe a high limit, I don't know. This is my first one of these INKBIRDs, so I'm just going through it here on the desk. This is the ITC-1000F F. I believe the F is for Fahrenheit. I don't know if this one. I don't think I can. I think. I think this one might be able to be selectable. The Fahrenheit or centigrade, I believe I can. But we'll see here. Let's see, relative. I know the relays are only good for 10 amps, so you want to use an external relay with this, and you always should anyhow. With a digital temperature controller, just get in the habit of always using an external relay or a contactor, and that way you don't blow up your controllers, you know, because only 10 amps, it's not smart. Any compressor, you know, draws like 7 times run load on startup, you know, and it's not going to do it. So just use an external relay, or a contactor is even better. You know, use yourself a 30 amp contactor, you know, for like little refrigerators, and you'll be whistling Dixie. It's the best way to go all the time. Or those, I'd prefer contactors, but I guess you could use one of those Omron relays, the rectangular ones that True uses. I don't have one handy in front of me, but you guys know what I'm talking about. They're like a brownish kind of color. They're like 2 inches long by 1 inch by 2 inch tall. You know, little rectangular guys. You know. Anyways, getting off channel here. Anyways, so I just powering this thing up. Got the error. So just so you guys know that there's my volts AC right here. I'm going to meter. Let's see if I can do this with one hand here. Hope I can. Hang on, let me put the foot for a second. Okay, these are a little close together, but anyways. And there's your 119 volts. So we know that it's not like erroring on like low voltage or high voltage or something. So I want you guys to see that. So that's out of there. So just wanted to show that to you, and let me power it down. Let me hook up the thermistor to it. Oh, by the way, I ohmed out these thermistors, and these are 10,000 ohms at room temperature. It's 73 degrees in this room, and the ohms on it are 9.9995. So basically 10,000 K ohms, which is K means 1,000. So when I put it on ohms, this is a 10,000 ohm resistor. So I just thought you guys would like to know that at ambient. So if you're checking your thermistors, and the book says here it's NTC. So, and that's that. Got here. All right, let me hook up a sensor. Okay, this is the INKBIRD digital temperature controller. iTC-1000F, and okay, so all wired in. I've got the main power wires and 10,000 ohm at 72 degrees, 73 degrees in the house here. Sensor hooked up, and it does say here that Fahrenheit and Celsius display can be chosen. For this is made in China, so the English is going to be a little different. Switching between cooling and heating modes. Control the temperature by setting temperature set value and the difference value. It also has refrigerating control output delay, which is mandatory for me. I always have do a 5-minute compressor time delay. Everything I do always has a minimum of a 5-minute time delay. Whenever a compressor goes off, I never let it come back on. unless for 5 minutes. So, an alarm when the temperature exceeds the limit, and there's you got your measuring range. So you got accuracy. So we're good for minus 50 to 210 degrees Fahrenheit. So yeah, it'll do freezer down to minus 50. You know, coil temp, you know, 10 or 20 degrees, or for coil temp, or box temp at 35 degrees to 41 and stuff. So should work, hopefully. Plus or minus 1 degree accuracy, resolution, 1/10 of a degree Fahrenheit, which is all great. Power consumption, less than 3 watts. Let's see. You fire this thing up. Okay. Just turned it on. Okay, so there's the power. Just turned it on. Okay, it comes out C because it's made in China, so they're gonna do. It's gonna be set up for 24 degrees C is what it's saying for the room. Let me see. I wonder how I change the. I think maybe S. I don't know. Let me see. See how to change the Fahrenheit, centigrade, and Fahrenheit on this thing. Operating instructions. Let's see, check your parameter. Let me get back to you in a minute. Okay, world. More with the INKBIRD controller. So, I've got it all wired in, and what I have going on here is these are the cooling set of contacts right here. Just a set of contacts, 7 and 8. So basically what I did is I just put my meter on ohms. So this is on tone. So right now the contacts are open. Okay, so when those contacts close, the meter will tone. Easy way to check your meter. So right now, I just put this thermistor, the sensor, in a cup with a few ice cubes. Okay, so I got probably 10 ice cubes in there, and it's kind of cool. Only took about, it's only been in there about a minute, and reading pretty accurately, I guess. We'll see. Plus or minus 2 degrees is acceptable with any digital meter, just so you know. So I don't know about having a calibration screw, or if they have. I doubt if there's probably some way to calibrate it, I guess, inside, but I'm not going to get into that. So you're always going to have stuff off by a bit. So ice cubes should be 32 degrees. So we're off by 0.8 of a degree or something, probably, maybe a degree. Right now it's looking like we're off by 0.8 of a degree. So not a big deal. Right within specifications. That's fine. Took a minute to check that out. So anyways, so we know it's 32 degrees in that cup, and I'm going to put the sensor in my hand, so we know body temperature's around 80 or 90 degrees on the outside of your skin, 98.6 inside. So I have this set for 60 degrees and 10 degree differential, so at 70 degrees, there we go. At 70 degrees, she tones out. That's a tone. That means the set of contacts closed. So they closed at 70 degrees. It's in cooling mode. Okay, it's 80 degrees between my fingers right here. So now I'm going to stick it back in here. Since I have a 10 degree differential, the set point on my controller, as you can hear, we've got tone, which contacts, so that means that the unit's cooling. It's in cool mode. It's set for 60 degrees. So when the controller hits 60 degrees, that tone should turn off. That'll tell you that your controller working properly. Boom. We're off. So you tell she's satisfied. She's off. What is kind of wild is I guess when it gets below your set point by 10 degrees, it actually switches into heating mode. I think. We'll see in a second here. Yeah, it does. Which is the other set of contacts. So that's kind of wild. If it gets too cold, you could do something that if you needed to warm up the box, you know, so that's pretty cool. So anyways, but that's it if it's on the other side of the differential for heating mode. So pretty cool. So anyways, so we're back at set point, which is 60 degrees. Now we're raising to 70 degrees. There we go, back into cooling mode. So works good. Controller, you can tell we're toned. So that's cool. So now flip that off. We don't need that anymore. And I was just going to run through how you set up the controller. Okay. This controller right here has there's a bunch of information right here. You can read that, stop the video, read it for yourself. But degrees Fahrenheit, when the set temperature is degrees Fahrenheit, you've got the codes. The different set points are TS, DS, PT, CA, and CF. So your TS is going to be your temperature set point, default of 50. So I've got it set at 60 right now. Differential 1 to 30, default of 3. I've got it set for 10. Compressor delay, that's your 0 to 10 minute compressor protection. So PT for protection. TS for temperature set. DS for difference set. Your temperature calibration value. There's your calibration that I was talking about. So if you wanted to put in a you could put in an offset of 1 degree if you wanted to calibrate it. And then you have your CF, which is your setting. Either C stands for centigrade or Fahrenheit. CF meaning centigrade or Fahrenheit setting. Default did not come defaulted F. It doesn't. So it was well, the whole controller was set for C. So anyways, it's either here nor there. So anyways, so I haven't heard the alarm though for an over temperature alarm. So when the measuring temperature exceeds the temperature measuring range. Oh, that exceeds the temperature measuring range. Total starts over temperature. Okay, so basically, this is pretty cool. I'll run through the what you do is you hold down the set button here. 1, 2, 3, 4, 5, 6. There's your temperature set. Then you hit set again. I told you it was set at 60. Okay, then up you got your DS, which is your differential set. I got it set at 10. Let's see if I can get the. Okay, there we go. Your protection setting. I got it set to 0 right now. You could set it for 5 minutes, like that. And you hit the power button real quick for setting that setting, and you hold that down 1, 2, 3. Temperature set 60. Differential set 10. Protection 5. CA, I think it's calibration. Yeah, temperature calibration value 0. Centigrade or Fahrenheit, Fahrenheit F. And back to your TS. So 1, 2, 3, 4, 5. So you got 5 windows. TS, DS, PT, CA, CF. 3, 4, 5. Yeah. So temperature set 60. So that's what I have it set. Power brings you back to your display. You got your Fahrenheit. Pretty cool. And you hold it down 1, 2, 3, 4, 5 for powering the whole thing off, and then like 1 second to turn it back on. I think you hold down for 3 seconds to turn it off. Then your blinking is your 5 minute on the cool. See the blinking light? That's your protection. That's your compressor protection. So in 5 minutes that will go back. That will be solid light, and your relay will click. You'll tone out. So just hang on. Let me see. Let me turn on the meter again. So that's just turning my meter on. It always does a tone when you turn it on. So I'm going to go to, see, we're blinking. That means we're in protection mode. So we hold the set button down for 3 seconds. Go to your protection and go down to 0 and hit the power button, and you see it relay. She toned. You got it. Your relay kicked in, went solid on the red light on cool. So that's set in there, and you can go back to your set and protection. See it's 0. So and power down 1, 2, 3, 4, 5, 6, 7. All right, supposed to power off. There we go. You hold your power button down and power's off. Okay, so that's the run through. Pretty much on the INKBIRD. And there's let me do a part of the book here so you can read this for yourself. Stop the video if you want to. Whichever things you want. Flip the book over. And like I said, you can stop the video yourself if you want to read something like that. It's that book. And this is the FAQ, frequently asked questions. Okay, so that's that. 10 amps on your relay contacts again. There's your sensor. So your line and neutral, 1 and 2. 3 and 4 is your sensor. 7 and 8 set of contacts. So you got that. Compressor. You got some that. And this has a 1-year warranty on there. This is this stuff. There's your QR code. And also what we got here is a business, this all comes in the box. INKBIRD warranty. That's that, I think. So everything comes in a cool little box like this. So that's everything. That pretty much does it. And this little cover goes over the back here. It just slides straight on like that. There's a little pin that sticks out right there, and it just slides into it. If I didn't have my test leads in there, anyways, you just slide it on and it covers for hair. But this is kind of nice, you know, when you take that little cover off, it's just held on by one little screw. You can just troubleshoot that way. You can check your power, but I don't recommend, you need to take the sensor wires out. I don't recommend, I mean, you could check for an open or a short just right here, but if you want to actually ohm the sensor out, you need to remove at least one wire to ohm out the wire. And the screws I'm using, you want to use it's a real small, it's smaller than a number 1. It's going to be your thermostat screwdriver, so it's going to be pretty darn small screw. So it's smaller than a number 1. Just a real small screwdriver. I don't know what they call this. I think these are called jeweler's screwdrivers. But anyways, I think that's about it. Alright, thanks for watching, everybody. And click like on the video if you could. And subscribe. Alright. And take care, y'all. Alright, take care. Bye. Okay, some bonus footage. Let's run this thing down to, let's see. Let's make it put it in a box here. Run it down to see how far it'll, see what it looks like at it says it'll do -50. So let me hit the set button here. And temperature set. Set at 50 right now. Let's run this thing down and see if it'll. Alright, there's -10, -30, -40. So there's what -50 looks like. Hey. Look at the face on the over at the cool with the 2 dots. That's pretty cool. Anyways, you hit the actually, so hold down the set button again. 1, 2, 3. Okay, temperature set. Hit again, blinking. So you run it down. So I want to set this thing. I'm going to set this thing for a cooler. So I want to do set it for 20 degrees. Okay. And then I want to do a differential set of, let's say if we're controlled by evap, controlled by evap temp, so we set it 20 degree evap, and then about a 19 degree for our differential. So I want the evap to pull down to 20 and a differential of 19. That means it'll come back on at 39, which will give the evaporator some air defrost time, because it'll be above 32 degrees. It'll start air defrosting at 33 degrees, and then we've got so it would be 6, so 32 and 9, so 7 degrees above, will be 7 degrees above freezing, so that should give it lots of time to air defrost. There'll be probably end up being a 10 or 15 minute evaporator air defrost every cycle. So that's why that works good. And that's it. So she's in cool. She's set for 20 degrees. And you can tell by the relay is pulled in because the cool button is solid red. It'd be off. There would be no cool light there if it was, the relay was open. It'd be blinking if it was in time delay. So, and I also want to set my compressor protection. So I want to set, there's 20 for my set point, differential 39. Protection on the compressor, I want to be 5 minutes. So, alright, and calibration 0, centigrade or Fahrenheit, CF, centigrade or Fahrenheit, we're at Fahrenheit, temperature set 20, differential set 19, protection of 5, calibration 0. That's it. And back to power button gets you back to the beginning. And that's your power button is your save button too. And then you just hold the power button down for powering off the unit or powering it on. Fairly straightforward. Pretty nice. I like it so far. Pretty cool. And so that's the INKBIRD ITC-1000F. And these things are about these are about five times cheaper than a Dixel or an Danfoss or whatever, and whatever other controller. So these are quite inexpensive and they feel well built. So I'm gonna run a couple of these locally and see how they last, and use them as a test subject. All right. So anyways, thanks for watching, guys, and click like on the video if you could, and subscribe. Take care. Bye. Okay. More bonus footage. There's what it looks like from the back end. Looks real nice. Looks real nice in there. Got some good weight to it, man. I'll tell you. It's like got some good weight to it. And this is how the cover, that little cover goes on here. That little pin sticking out right there, the cover goes over that. Okay, just slides on like that, like cover to cover. Keep the dust out of the inside of the controller, which is a nice thing for screw part. And then it just has a teeny little screw that goes in that screw hole. And makes it a little longer, but you could run it without that cover on it if you have issues. But and if you don't want the wires being hooked down like that, it might not be desirable. So it wouldn't be any big deal not running it without that cover. In fact, I probably won't do it because I know that any wires coming out, I don't like the strain, putting the strain on it like that. So I'd be running it without that cover on there probably, or probably what I end up doing, because I like the top part protecting the connections part. What I'm going to do is I'd take my dikes and I'd snip off the bottom half right across here. I would just snip my dikes across here, and just so I'm not bending. So I still have the protection on the top, but so it's not wrenching the wire, the main wire, your main wire coming in. I don't like it being bent. I wouldn't like it being bent over there. And my other wire that would go to my contactor over here. So That's what I'd do. Take my dikes, nip it off across there. Take about a 1/2 inch off of it. Just below that little tit sticking out there. So anyways, alright. Alright, so thanks for watching, guys. Click like on the video and subscribe. Alright. Take care. Bye. Okay, a little bit more bonus footage. This is what the sensor looks like that comes with it. Come on, baby. Focus. Let's see if I can. Here we go. So, looks pretty darn nicely sealed up. You could put it in a, put it inside of a piece of copper. You could stick a piece of copper. I don't think I'd want to stick it in an evap by itself. It would work, but I don't know for how long. But you could stick it, take a piece of 3/8 copper, stick it in a piece of 3/8 copper, and then stick a piece of 3/8 copper in an evap. And that's how you could control by coil temp. That sensor looks sealed up pretty good. Looks like a nice little sensor. Yeah, she looks sealed up pretty good. Nice little sensor. I don't know how long the wire is. Oh, I'd say 6 foot probably. I don't know, something like that. But anyways, pretty damn long. It's good. Got a lot of wire. So, let's see, 1, 2, 3, 4, 5, at least 6 foot. But anyways, okay, so that should be pretty good. All right, thanks very much. Click like on the video and subscribe. Take care. Bye.